Screen is visible, right, students?
Yes, ma'am.
So today we want to focus on experiment number 6, which is related to timing and delay related operation. Student, before this experiment, whatever we discuss to experiment 5, that is basically the programs related to our instructions, right? We have a different set of instruction. So that category we had first observed, and based upon that we have a few tasks. Now if you observe the experiment uh, 6 and above, you will check. Now we are implement some application by using these instructions. Again I'm repeating student, हम लोग ने instructions सारे पढ़ लिए, right? We had already discussed almost all instructions. Two three instructions are left which is related to income. Almost everything related to instructions we had discussed. Now by using this instruction, what are the different applications that is available into your course, and how we can implement it, that we will discuss in our experiment number 6 onwards, right? So more or less now onwards, all the experiment will be based upon applied level, right? हम लोग ने जो भी understand किया है, that we are going to apply. So just try to understand कि suppose if I'm designing a counter, if I'm designing a counter, पहले तो counter क्या है ये सबको पता है. What you mean by counter? What you mean by counter? Or where you find this counter? Yes. Any rough idea? Where we are
It
finding
is
counter?
variable
Yes,
which
Uday?
increase sequentially.
Yes. As an counter, you can consider some value. Either you will increment that value or you will decrement that value, right? For example, if we are talking about digital flow, we are incrementing a count value. If we are talking about shopping mall, where we are taking the items, so that is basically counting up. If we are talking about traffic booth, that is basically count down, right? So whenever we are finding a counter, हम लोग जब भी counter discuss करते हैं, the two type of counter will come in our mind, that is either up counter or the down counter, right? Okay, we are taking the value 0 0 initially, and we will count up, or we are taking the maximum value and then we are count it down, right? So this can be the two possibility to design a counter. Now just try to understand it through the theory first, and then we are going to implement it, right? Student, as I discussed in class, that this chapter we are not going to repeat in our theory session, because all chapter is almost based upon implementation, right? So instead of doing it in theory session, we'll do it in our practical session, right? And of course, experiment number 6 is based upon this concept of counter and time delay. Now, if you will observe this chapter or particular module, you will observe that two important part here, or two important uh, points here we want to make: how to design a counter and what is the requirement of time delay, right? So basically, we'll first try to understand what can be a design steps, or how can we design a counter. Counter हम लोग ने सबने देखा है. We all have used this counter, but how to design that counter, that is not known to us, right? हम लोग ने very first lecture से we are taking an example of traffic, we are taking an example of home appliances, right? This examples we all every day we are using digital clock. Every day we are experiencing, but we don't know how to design it. So first we will discuss how to design a counter, and then we will move to the time delay. Right, so this will be the outline for today's lab. I hope my screen is visible, right, student? Is it visible to you?
Yes, ma'am. Ma'am, can you tell what we have to submit in experiment 5?
Yes, I'm not getting your voice properly. Can you repeat, please? Hmm? Who is asking?
What
Uday.
we have to do in experiment number 5?
It is already written. See, suppose if you observe your Google Classroom. In experiment number 5, Uday, we had discussed 6 tasks, right? Out of that, you need to write any 5, and that I had that I had plotted over here, TC2, right?
Yes, TC2.
Yes. Can you see here, Uday, left 5 questions,
Yes, yes.
right? So from here, you will get 6 tasks. Out of that, any 5 you need to write, okay? And that I had
Okay, ma'am.
plotted, yes, that I had plotted whenever we declared this assignment, right? Okay, just take it from there. Okay, any doubt now, Uday? Can we move ahead? Okay.
Yes, ma'am.
Okay. Now this can be the outline for today's lab, where we first focus on counter. So focused on counter, that means how to design a counter, that we will discuss. Then we'll move to the time delay. Then one or two program related to up counter and down counter first we want to discuss. And then if time permits, we'll move to the pulse or waveform generation, right? So first 3 point at least we should be clear with at the end of the lab, right? Now just try to understand counter first. A counter is designed by simply loading an appropriate number in one of the register. An increment or decrement, that instruction will be used to increment and decrement your counter. Now suppose if I'll say this is nothing but the design step or the definition by design of my counter, right? How I will design my counter. So for that few steps are given, that I need to load an appropriate number. Need to load an appropriate number into one of the register, and then depending upon whether I'm designing an up counter or I'm designing a down counter, depending upon that I need to use increment or decrement instruction. Okay, once I do this task, what can be the next step? The loop is established to update it. Let's say for example I'm designing a down counter. Try to understand, student. I'm designing a down counter. So for example, I want to count from 9 to 0. So 9 should be loaded in one of the register. Then I will decrement it, right? So up to which point I'll decrement it. So when it will become 0, 0, up to that I will decrement it, right? So loop is established to update my count value, and at each and every count you will check whether it will reach to 0, 0 or not. If not, then it will go and repeat. If yes, then it will go to the hold state. Right, now just try to understand how to implement it. Right, say for example, this is my simulator. If you are here, then we can consider this on Keat. But right now, as you are not available here on campus, so we are trying to understand it through simulator. Now just check it. Suppose if I am designing a down counter, my screen is visible to all of you. NBI A 09H. Right now what I am doing is I am designing a down counter which will count down from 09 to 00. Then after loading my register, what I'll do is I'll decrement it. I'll check it whether it will become 00 or not. If no, then decrement again. If yes, then go. this counter will work. Say for example, मैंने यहाँ पे 9 is loaded into the accumulator through MVI instruction. Now what I'll do is I'll decrement it. Can you see here? It will become 8. Then again, I'll check the condition whether it will become 0, 0 or not. It is not 0, then again it will go and decrement. It will become 7, 6, 5, 4, 3, 2, 1. ये loop से बाहर कब आएगा? When it come out of the loop? Yes, when it will come out of the loop? My audible students? When this will come out of the loop? अभी देखो यहाँ पे 1 हो गया है. Can you hear me, students?
Yes, ma'am.
Okay, ये loop से बाहर कब आएगा? When this
ये
content
zero
of
हो जाएगा तब.
yes, when the content of accumulator will become 0. Now you just see it. It is 0 now. Now it will go to the hole. Right? So जैसे we are using a digital clock or any counter which will count down, the procedure to design that counter will be same. Right? आप count digital clock में क्या करते हो? Initially you are loading it with 60. Stopwatch counter में 1 to incremental you are incrementing your counter. So whenever there is a need to count down, every time we are following the same method, we are loading our register with the maximum value. Then we will decrement it. We'll check whether it will be 0, 0 or not. If it is not, then go and decrement. If it is 0, then come out of the loop, right? So any doubt here in designing of down counter? Anyone? How to design a down counter? Is it clear? Yes or no? To how
Yes,
many
ma'am.
of you it's yes. To how many of you it's clear? Ayush? Devang? Devang says yes. Sakshi? Shruti? Okay, Sakshi, are you here on campus?
No, ma'am, I am
Sakshi?
at home. Ma'am, I am at
Okay.
home right now.
Okay, Uday, is it clear? Okay, now student, just tell me
Ma'am.
that this is my, yes, yes please.
मैम JNZ है वो एक्यूमुलेटर को ही चेक करेगा ना.
Yes, see any conditional instruction will check the instruction before that, right? यहाँ पे अगर मैं DCR-B लिखूंगी then it will check register B. आपकी ये conditional instruction से पहले कौन सा instruction है that it will check. Am I clear, Mukul? Right?
Yes, ma'am.
Correct. Okay. Now student just tell me कि this is my down counter. Now I want counter. Where should I change? Where should I change? मुझे up counter design करना है. I want to design an up counter. So what do you think? Yes.
Increment.
Okay. Very first change that everyone can find here is instead of decrement, it should be increment. Okay. Now, if I'll say I'm incrementing, that means my initial value should be maximum value or initial value?
0.
It should be correct, 0, 0, right? So initially I'm loading my register A with 0, 0. I'm incrementing it. अब सोचो स्टूडेंट कि अगर मैं ये इंक्रीमेंट करूंगी, so is it possible that it will become 0? ये इंक्रीमेंट करते करते कभी भी ये 0 होगा? Yes or no?
No.
No, not possible, right? Correct. So what we should include here that whenever you are designing an up counter, हम लोग को सबको पता है कि say for example, if I say I am designing an up counter and I want to count up from 0, 0 to 0, 9. After 0, 9, my counter should be stopped or it will again load to the minimum value 0, 0. मुझे decimal counter design करना है. Simple. I want to design a decimal counter. So what I'll do is initially I'll load it with 0, 0, I'll increment it. Now 9 के बाद it should not count. What it means कि I'll compare my value of accumulator with 098. If my count value and my predefined value are same, then zero flag will set, and then again then it will go to hold. If both are not same, that means your zero flag will not set and you have to go in increment. Am I communicating, students? The use of CPI, comparison instruction, right? Whenever you are designing the up counter, what is the maximum or a predefined value that you want to go for up counting, that you need to first decide. Are you designing a decimal counter, hexadecimal counter, right? You are designing a modulo 2 counter, any counter you are designing, that maximum value that you want to go for, that you need to decide first, right? And based upon that, you will compare your predefined value with your count value, right? हमारा count किस में है? And our count is available in accumulator, but we are comparing with 0.9 because we are designing a decimal counter, right? Now just try to understand that how this up counter will work. You can check here that initially the accumulator's content we are taking, that is 0, 0. We'll increment it so it will become 1. We'll compare it with 0, 9. Obviously 1 and 9 are not same, so 0 flag will not same, are not set. So again it will go and increment. Can you check here, student? 2. Right, again it will go and compare. It will become 3, 4, 5, 6, 7, 8, 9. Now once you will reach to 9, your predefined value and your count value are same. So 0 flag will set. You can see here 0 flag will set and you can come out of them. Are you getting me, student? How to design a counter, up counter or down counter? Yes or no? Is it clear? Yes. Am I communicating, student, how to design up and down counter? Is it clear? Harsh? Devang?
Yes, ma'am, clear.
Okay. Mukul? Sakshi, is it clear? How to design
Yes, ma'am.
up
Yes.
counter and down counter, right? Now just try to understand, student. Now just repeat these 2 lines that we had checked. A counter is designed by simply loading an appropriate number into one of the register. मतलब if you are designing an up counter, you need to load 0, 0 into register. If you are designing a down counter, you will load a maximum value that from where you want to count down, that you will load into your register. So loading an appropriate number into one of the register, then increment or decrement it, right? So if we are designing an up counter, we will increment the value of register. If we are designing a down counter, we are going to decrement, we are going to decrease the value of register. So increment and decrement registers, increment and decrement instructions are used to modify the count value. Then loop is established to update whether you will reach to the maximum count or you will reach to the 0. Based upon that, you will repeat your loop, right? And that is nothing but you are designing a counter. The type of the counter can be up counter or a down counter. Are you following my discussion, student? Right, this slide is clear. Any doubt here in the slide, anyone? Okay. Now the same thing you can understand through flow chart as well. What we are doing is initially we first decide whether we are designing up counter or down counter. We'll initialize it, we'll display, we will update, we'll check is this final count or not. If not, then go and display. student, he entered a down counter. Now suppose student, if I say I'm designing an down counter. I'm designing a down counter which will count down from 09 to 00. You will always find an application of counter where your counter will not count only once, right? हम लोग ट्रैफिक पुलिस पे है या फिर डिजिटल क्लॉक we are observing, yeah, we are going for the shopping and we will check that. So the counter will not increment different once, but it will continuously counting. आपका 9 से 0 then it will become 00, again it will load to the 9. So what I mean trying to tell you is, generally whatever counter value or whatever the counter you are setting, you are designing, that is general that kind of counter. तो स्टूडेंट यहाँ पे मैंने लिखा था कि अगर मेरा काउंटर 00 हो जाए then it should go to hold. Now instead of that, if I want to make it continuous, what change I should do? I want to make it continuous. अगर ये 00 ना हो जाए, then it will go and decrement. But if it is 0, then again it should go to the 9. It should load the maximum value. So what I should write? Mukund, Harsh, are you getting my point? Students, Uday, are you getting my point? What I am trying to tell you? Yes, Harsh. Go ahead. Yes. Sanskar, Mukund, Devang. What do you think? To make it continuous, where we should change? देखो आपने counter will not count once, but it is continuously repeating, right? So my question is, how to make it continuous? Follow? Sakshi, what is your point? My voice is getting, student?
Yes, ma'am, sometime.
Yes, ma'am.
Yes, ma'am.
Students, are you getting
Yes,
my
ma'am.
voice? Okay. Okay, just a minute. Are you getting my voice properly now, students?
Yes, ma'am.
Okay, now it's clear? Okay. So the last point that we want to discuss here is, suppose student ये हम लोग ने काम कर दिया, my screen is visible, right?
Yes, ma'am.
Correct. So what we discuss is, here we are designing a down counter, but we don't want कि ये एक ही बार count करके loop से बाहर निकल जाए. We want to make it continuous. Once it will reach to 00, Again, it will go and load 09. So what I should write over here? That is the question. How to make your counter continuous? What do you think? Yes? Any idea, any rough idea what can be done? Dinesh? स्टूडेंट यहाँ पे हम लोग कंडीशन लिख रहे हैं जे एन जेड इफ this counter will become 0 then it will come out of the loop. So here we will write if 0 flag is not set then it will go and decrement. So if 0 flag is set then it will go to L2. Am I communicating student? अगर 0 flag set नहीं होगा तो वो loop में जाएगा और अगर 0 flag set होगा then it will go and load my counter again. Am I communicating student? Right, suppose if you are executing this, you can check, yes. Now you can check, once it will become 0, it will go and load initial value, right? So this counter will never come out of the loop, right? This is known as continuous counter. Student, you can try by run all at a time. Can you see here, student? It is a continuous counter. Yes or no? Are you getting my point, student? How to design a continuous counter? Hello?
Yes, ma'am.
Yes. Someone wants to discuss something? Yes. Is it clear, student? Right? Okay. This counter will stop whenever I'll force this to stop or I'll reset or I'll switch off my system. Right? अगर मैं यहाँ पे forcefully उसको stop करूँगी और I'll reset my system, then only this counter will stop. Otherwise, continuously it will count up or count down. Are you getting me, students? Right? Now suppose if I'll say कि मैंने JNZ लिखा उसके बाद JZ लिखा, if anything will not come into mind, you must know कि अगर मैं JMP लिखूंगी, jump unconditionally, right? So if this condition is not fulfilled, then it will directly jump to L2, and that also will work by same manner. You can observe here. Yes or no? Right? This also can be worked as per our requirement, that will count down, and that is also a continuous counting down of our value. Right? Any doubt, student, up to here? How to make a continuous counter? Anyone? Yes, sir.
No, ma'am.
Everyone, if it is clear to you, you will raise your hand. If it is not clear to you, you will ask the question. To Mukund, that's clear. Okay. What about others? Student, is it clear to you?
Yes, ma'am.
Devang, it's clear. Dinesh is clear. What about Ayush, Naseeb, Sanskar, Madhvi, Krunal, Harsh, Vishwa, Shubham, Shruti, Savan? I hope this is clear, right, student? Now, student, just tell me, if I am designing my counter like this, and you have observed the counter at different places, what do you think? That counter is like this, that you are not even able to observe? यहाँ पे प्रॉब्लम क्या है? The count down हो रहा है, but can we observe it? Yes sir. Are we in a position to observe it? No. Can we observe it, student? आप यहाँ पे देख रहे हो कि count down तो हो रहा है, right? The counter is decrementing, but in application where we are using this count down counter, we can see कि वहाँ पे we can observe that count value easily, but here we cannot observe. What is the problem? Yes. What is the problem? Sakshi, what do you think? What is the problem that we design and the counter that we are observing in a different application? What is the difference?
No idea, ma'am.
Okay. Mukul?
I'm not getting a question.
My voice is coming properly, student?
Yes, ma'am.
Okay. So my question is, student, कि यहाँ पे आप counter देख रहे हो, right? You are designing a counter. It is working properly. You can say step by step. If I'll go, I can check कि ये count हो रहा है, right? But whenever I'll execute it, I'm not able to observe this count value. जो कि हमें real time में जितने भी counters हम लोग देखते हैं, वहाँ पे we are easily observe this count value, right? Here it is not easy for us to check for the count value. Are you getting, Mukund? What I'm trying to tell you is, यहाँ पे count down हो रहा है, but you are, can you observe it कि यहाँ पे अभी क्या count है?
No, ma'am.
No. So what is the problem? What do you think? प्रॉब्लम क्या हो सकता है? एनीवन? यस,
मैम वो इनफाइनाइट है तो काउंट करता ही रहेगा ना?
काउंट करता रहेगा, बट काउंट वैल्यू भी मुझे दिखना चाहिए ना. माय क्वेश्चन इज व्हाई आई एम नॉट एबल टू ऑब्जर्व दैट काउंट वैल्यू. जैसे हम लोग ट्रैफिक बूथ पे होते हैं तो वी कैन इजीली ऑब्जर्व कि 58 सेकंड हुआ, 57, 56, 5, 4, राइट? वी कैन ऑब्जर्व इट, बट हियर वी कैन नॉट ऑब्जर्व. व्हाट इज द प्रॉब्लम?
You have to add delay.
यस देवांग, प्लीज रिपीट.
1 सेकंड का डिले ऐड करना
Devang,
पड़ेगा.
you are not audible. Can you repeat one more time, please? You are on right track. Yes, Devang. Yes, what is the? Yes, Devang, go ahead. Your voice is cracking. We are not able to hear you. Yes, Devang, you can write it over here in chat box. What you are trying to tell. मुकुंद, दिनेश, आर यू गेटिंग द पॉइंट? हम लोग जहाँ पे एप्लीकेशन में देखते हैं काउंटर, तो वहाँ पे इजीली वी कैन ऑब्जर्व द काउंट वैल्यू, बट हियर वी कैन नॉट. Yes, we cannot check this counter value, and that is due to we are not adding sufficient delay in between to count value. So student, just try to understand कि ये मेरा 9 है यहाँ पे, और वो मैं 9 में से 8 कर रही हूँ. I'll make it 7, 6, 5. So in between that, I'm not putting some delay so that my value can be hold up to certain period of time, right? So always necessity is, whenever you are designing a counter, whenever you are designing a counter, along with that counter, you need to give some sufficient delay in between to count, so that for that period of time you can hold your data onto the display, right? So how to design a counter, that is clear to us, but now the question is how to put delay in between to count value. That is our next point that we want to discuss. Are you getting my point, Sakshi, Vishwa, Dinesh?
Yes, ma'am.
Yeah,
Everyone? Correct, right? So whenever you are designing a counter, that is a task that you are doing is half. But along with the counting value, you need to take care that we have to provide some delay in between two counts so that we can observe it. आपने ये चीज कहाँ पे ऑब्जर्व किया होगा कि जहाँ पे भी आप स्लो रिस्पॉन्डिंग पेरिफेरल लगाते हो, राइट? फॉर एग्जांपल, यू आर कनेक्टिंग योर कंप्यूटर एंड प्रिंटर. We all can understand that how fast our computer will send the data to the printer, or printer cannot print with that much speed. Are you getting me? So in between that we are putting the buffer. Buffer is what? It will do nothing, but it will only hold your data for a certain period of time, and that is you are providing a delay in between your transmitted signals and received signal. Are you getting my discussion, student? So always, whenever we are designing a counter, along with that counter, we need to always think of the delay, and that is our next point with this. Now, how to provide a delay in between two count value, right? So time delay we want to, right? Now, before we are starting with the time delay, just to make you revise, what are the type of counter that we discussed? What are the type of counter that we discussed? How many type of counters we have? Yes. Yes. How many counters? How many type of counter we are having, Sakshi? Whenever you are designing a counter, what are the type of counter? First, what you decide? Yes. Students, are you getting my voice or not?
Yes, ma'am.
Okay. So, what are the type of counter?
Ma'am, up counter, down counter.
Yes, two type of counter, that is up counter and down counter. Now the way you are taking the register and increment of decrement of register, that is different in both the cases. You are designing a up counter, accordingly you need to take care. You are designing a down counter, according to you need to take your value. Now after that, the second point is we need to discuss is about delay. Now, how to provide a delay, that we need to understand. Now, as I discussed, that there is a requirement to put delay in between two count value, and we have total 4 methods for generating a delay. Are you getting me? We have 4 methods to provide a delay in between two count. We'll discuss it one by one, and we will check that how this methods are delay and how much delay we are getting. Am I communicating, student? The requirement is, even if you are designing a counter, you are not able to put, you are not able to see, you are not able to observe your count value. Why? The reason is you are not providing sufficient delay in between two count value. So what to do to provide a delay in between two count? So we have these 4 methods which will give us a provision through that you can provide, you can give a delay in between two count, that is by using NOP, by using register, by using register pair, and loop within a loop or nested loop, right? Any point discuss, you want to discuss here, student? Anyone? Yes or no?
No.
Student, as I discussed with you, that anyway we are not going to repeat this into a theory session, that there, so that make sure that you will write this thing into your class workbook. Okay, so this can be the 4 methods through that. Am I audible, right, student?
Yes, ma'am.
Correct. So this can be the 4 methods through that you can generate a delay. Now just check one by one. A very first thing is NOP instruction. Now student, NOP instruction itself give us a description for the instruction that it will perform nothing. NOP matlab no operation. NOP is no operation. That means if you are writing this instruction, it will do nothing. Then why we are using this instruction? So obviously to provide a delay, to pass our time. Right? Say for example, if I say that I'm writing NOP instruction, I'm writing NOP instruction, you can check that this instruction will do nothing, right? The equivalent code for this instruction is 00, it will do nothing. Then why we are using it? Suppose here I am having a count value and here I am updating my counting, राइट यहाँ पे मेरा काउंट वैल्यू है और यहाँ पे मैं उसको अपडेट कर रही हूँ इन बिटवीन दैट इफ आई राइट एनओपी सो इट विल डू नथिंग बट इट विल provide some delay. It will hold my previous input for a certain period of time, and that is nothing but that we want to do. We want to pass our time in between so that we can display that result, right? So NOP is the one instruction where you are doing nothing, no operation will be performed. It will only provide you delay. Now, as I discussed that NOP will provide you delay, but how much delay? Delay मिलता है, but कितना delay मिलेगा? That also we need to check for yes or no, right? If I say this NOP will give me a delay, how much delay? That we need to check for. Now we are calculating students with NOP. With first method, we are getting how much delay. Okay. Now just try to understand. If I am writing this NOP instruction, it will only take one machine cycle, and that is opcode fetch. It will take only one machine cycle, and that is opcode fetch. Now can anyone tell me कि opcode fetch machine cycle will take how many T state? Opcode fetch machine cycle will take how many T state?
Six.
Yes. This NOP instruction take only one machine cycle. Can you hear me, student? Which is opcode fetch. So opcode fetch machine cycle will take how many T state? Yes?
Four.
4 T state, correct. Right? It will take 4 T state. Now if I say this instruction will take 4 T state, how to find T? इसमें हम लोग T कैसे find out करते हैं? How we are finding out T? Yes? How we are finding out T? इसमें T कैसे find करते हैं? So we should know कि ऑपरेटिंग फ्रीक्वेंसी ऑफ ईच एंड एवरी प्रोसेसर इज फिक्स, राइट? जैसे कि हम लोग ने स्टार्ट किया था, एट दैट टाइम वी हैड डिस्कस कि ऑपरेटिंग फ्रीक्वेंसी ऑफ आवर क्लॉक फ्रीक्वेंसी ऑफ आवर माइक्रो प्रोसेसर इज 3 मेगाहर्ट्ज to 6 megahertz, right? Like same way with any processor, your operating frequency is fixed. Let's say for example, if I am taking is 2 megahertz, if I am taking here is 2 megahertz, then what is the value of T? अगर मेरा F 2 megahertz है तो फ्रीक्वेंसी के ऊपर से हाउ कैन आई फाइंड T? Yes, what is my value of T? Make it fast, student. How can I find T from F? F equal to
1 upon T.
1 upon T. So if my F is 2 megahertz, then T will be 1 by 2 microsecond, which is 0.5 microsecond. Yes or no?
Yes, ma'am.
Correct. Now if I say okay, my T is 0.5 microsecond and my NOP instruction will take how many T? 40. So delay I'll get through NOP, delay that I'll get through NOP will be 4 into 0.5 microsecond, which is how much? 4 into 0.5 microsecond is how much? 2 microsecond, right? So if I'll write NOP instruction in between two count value, you will get a delay of 2 microsecond, right? So that's why they are saying that they are getting a delay in terms of microsecond, so which is nothing but the smallest delay that we can get through NOP instruction. As I discussed, that suppose if you are considering your f equal to 2 megahertz, your delay equal to nothing but t state and clock period. How you will find the clock period? That is through 1 by f. So you will find your t equal to 0.5 microsecond. While executing NOP instruction, you will take 4 t state. Only one machine cycle will be executed, and that will take 4 t state. So 4 into t, that is 2 microsecond, right? So 2 microsecond delay will be generated using NOP instruction. Am I communicating, student? Yes or no? Right? So suppose if I want a delay of 10 microsecond, for example, then how many NOP instruction I need to write? Yes. Suppose I want a delay of 10 microsecond, how many NOP instruction I need to write?
5.
5 times NOP, NOP, NOP I need to write, right? So you all can observe that this 4T state we are taking, and depending upon the operating or a clock frequency of our processor, we are in a position to find our equivalent delay for this instruction NOP. But this instruction is useful whenever you need a few microseconds delay, right? आपको जब भी in terms of microsecond delay चाहिए, at that time you can use this pause method, right? But thing is, suppose if I say I want to generate a delay that is in terms of millisecond or second, obviously this method cannot be used. Am I communicating, student? ये बहुत ही लेस डिले फाइंड आउट करने के लिए है, लेस डिले प्रोवाइड करने के लिए, विच इज इन टर्म्स ऑफ microsecond. Suppose if I want 1000 microsecond, then obviously it is not possible for us to use this, right? So what you need to do is you need to move to the second method, which is using register technique, right? The first method, very simple. By using one instruction, which is NOP, you can provide a delay in terms of microsecond, but it is a very small or less delay that you will get. Whenever you want to more delay, आप सोचो कि अगर माइक्रोसेकंड का डिले भी हम लोग देंगे, then also we can not hold our count value onto the display, right? There are some application where there is a requirement to provide a delay in terms of microsecond. At that time, you can use your NOP instruction, right? So, with this limitation, we want to discuss our second method, which is using register technique, right? Now, before starting with this technique, just tell me how many 8-bit registers we are having. In 8085 microprocessor, we are having how many 8-bit register? BCDEHL, okay. Any addition into this 6 register? How many 8-bit registers we are having? Sakshi says BCDEHL. Any other register? This is also having 8-bit. Yes, Mukul? Okay, Sakshi, in accumulator you can store how many bits?
16.
Accumulator में आप कितने bit store कर सकते हो?
16, ma'am. 16.
Accumulator में you can store 16 bit. in accumulator. Can you load 16-bit Sakshi?
No, sorry, ma'am. 8-bit.
Yes, only two 16 registers we are having, which are memory pointer is SP and PC, right? Take pointer and program counter. These two registers are only 8-bit, 16-bit stake pointer and a program counter. All other registers, that is accumulator, BC, DE, HL, are of 88-bit. Mukund, we have WZ register in processor, but that is not for the user. Right? WZ register hai, that is the internal for the internal operation of microprocessor, that is not available to user. So we are having total 7 8-bit registers, and that is BC, DHL and accumulator. Right? Agree? All of you are agree with this statement? Yes or no? We are having total 7 registers which can store 8-bit, and that is BCD and HL. Now student, try to understand or just give me answer. Key, suppose if I'll take any 8-bit register from BCD, HL or accumulator, if I take, I can load how much maximum value? How much maximum value that can be stored in any 8-bit register? For example, the minimum value in my 8-bit register I can load is 00. What is the maximum value that you can load? Yes? Question is, in your 8-bit register, what is the maximum value that you can load? Mukund, Dinesh, Sakshi, Devang, Shubham, Drasti, Naseed. Yes? What do you think? What is the maximum value that you can load into your 8-bit register? अगर उसके सारे बिट 00 है, that means 00 is minimum value. Then what is the maximum value, Dinesh? Yes?
FF.
Very good.
FF.
Very good. Very good, right? The maximum value that we can load in any 8-bit register will be FF, right? Now just try to understand by this logic how we are providing a delay, right? The maximum value that I can load into my register is FF. Why I am discussing this? So you can check here from the technique's name itself, we are using register technique. That means we will take any 8-bit register to store our data, right? Now just try to understand that with by using register technique, how much delay and how we are able to generate a delay. पहले हम लोग ये डिस्कस करेंगे कि रजिस्टर से हम लोग डिले कैसे जनरेट कर सकते हैं. Second thing, we will discuss how much delay we are able to generate. Are you getting me, student? पहला जो टेक्निक था, the first technique, that is by using instruction. NOP is an instruction, so that you can provide a delay. Second is we will use 8-bit register to provide a delay. Third method is we will use register pair to provide a delay. And last is we will use loop within a loop technique to provide a delay. First method we had already discussed. Second method, register basic, we had already discussed. Now how to generate a delay by using register, that we want to discuss. Try to understand, student. As I have discussed, first tell me, my voice is clear to everyone? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Now how to use register to provide a delay? As I discussed that FF is the maximum value. As I discussed that FF is a maximum value that you can store into your register. So here we are loading a register C with FF. No constraint, you can use any general purpose register over here, right? आप जब भी delay generate करते हो, to load your register, you can take any value. Now you will decrement that FF to FE to FD टू FC, कहाँ तक आप इसको डिक्रीमेंट करोगे? जब तक ये आपका FF से 0 0 ना हो जाए तक, राइट? दैट मीन्स आई विल एग्जीक्यूट दिस लूप FF times. If I'll say I'll execute this two instruction FF times, it is hexadecimal FF, मतलब binary decimal में क्या होगा? You will repeat this loop how many times? FF equivalent, very good, right? You can say you will repeat हेक्साडेसिमल में आप FF टाइम ये लूप को एग्जीक्यूट कर रहे हो, you are executing this loop FF टाइम, so equivalent डेसिमल इज 255 टाइम्स. मतलब मैं पहले मेरे रजिस्टर को मैक्सिमम वैल्यू से लोड कर रही हूँ. आफ्टर दैट आई विल रिपीट दिस प्रोसेस, दिस टू इंस्ट्रक्शन 255 times. And with this, what we are doing is, we are doing nothing. Simply we will put it into a loop so that ये loop में घूमता रहे और हमें delay मिलता रहे, right? We are getting some time. इससे पहले मैं यहाँ पे कुछ count लिखूंगी, right? Before this loop, I'll write some count value, and after this, I'll update it, right? So in between that, I'm putting this loop which will execute 255 times, so that I'll get some delay in between two count value. Am I communicating, student? Right? यहाँ पे before this, for example, मैंने count value लिया है 9. I'm taking the count value 9 and I'm updating it. That means I will make it 8, right? I'll make this count value 08. So in between this, I'll execute this loop for 255 times. So that will change nothing, but that will give me some delay, right? So that what we want to do, we want to pass our time in between to count value, and that we can do by using register. So that's why it is known as using register technique, right? Now, as I discussed, that this 3 instruction will give you some delay, but how much delay? That also we need to calculate, right? ये 3 instruction, this 3 instruction, you will write in between to count value. You are loading the counter, you are displaying it, and in between that, you will write this 3 instruction, which will repeat to 55 times. So, how much delay you will get? जैसे previous case में हमें 2 microsecond का delay मिला, वैसे इस case में हमें कितना delay मिलेगा? That we want to find. Now we are taking same F for here also, and that is 2 megahertz, right? Now just try to understand, student, कि ये मेरा loop कितने times execute हो रहा है? This 2 instruction will execute how many times? These 2 instruction are executing how many times? Am I audible?
Yes, ma'am.
How many times this 2 instruction will execute?
255.
255 times. And how many times this instruction will execute? आपका ये इंस्ट्रक्शन कितने बार आप अपने FF को C में लोड कर रहे हो? 1 time or multiple time?
1 time.
Only 1 time. So if I want to find the equivalent delay for this 3 instruction, I need to find 2 delays. अगर मुझे total delay find out करना है, T total, I want to find T total. Suppose if I want to find T total, what I'll do is I'll find outer loop delay. I'll find outer loop में कितना delay है, और plus I'll add this outer loop delay and loop delay. मेरा loop को execute करने में कितना time लगता है, और मैंने outer loop में जितने instruction, hello, yes, how much time I'll take to execute this instruction, plus how much time I'll take to execute this 2 instruction, that I'll add, that is nothing but my total delay. Am I communicating, student? How to find total delay? आपको outer loop का delay find out करना पड़ेगा और loop का delay find out करना पड़ेगा. Now try to understand how to find outer loop delay. TO कैसे मिलेगा? क्योंकि हमारा outer loop में एक ही instruction है which is MVI and it will take how many machine cycle? outer loop में एक ही instruction है which is MVIC and it will take how many machine cycles, Sakshi? Yes?
Ma'am, repeat the question, please.
In your outer loop, you have only one instruction which is MVI. So MVI instruction will take how many machine cycle?
Output fetch first.
Opcode fetch and memory read. So 2 machine cycle it will take, and opcode fetch will take 7 T state and memory read will take 3 T state. So total how many T state for MVI? 7 T state. So if I want to find outer loop delay, so that is nothing but 7 into T. And T is how much? T कितना है? अगर मेरा F2 मेगास है तो मैं T will be 0.5 microsecond. So ultimately 3.5 microsecond is my outer loops delay. Am I communicating, student? Any doubt up to here, anyone? Yes or no? Is it clear, student, how to find outer loop delay?
No, ma'am.
Okay. Now how to find loop delay? So for
Ma'am, not
finding out,
getting.
you are not getting? See, to find a total delay, who is speaking? Mukund, are you speaking?
Yes, ma'am.
Yes, who is there? Mukund.
Yes, ma'am.
Okay, Mukund, just try to understand. ये हमारे 3 instruction है for register technique. Now out of this 3, 2 are repeating. These 2 instructions we are repeating 255 times. Right, so that these 2 instructions are in loop. So we will calculate the equivalent time over here. Right, loop में हम लोग को वो calculate करेंगे. Outside the loop कौन सा एक instruction है? Only one instruction, and that is MVI. Now suppose if I say I want to find the total time requirement for executing this 3 instruction. But 3 instruction में 2 instruction multiple time repeat हो रहे हैं, एक instruction एक ही बार हो रहा है, and which is known as outer loop. Right? Now outer loop में आपका एक ये जो instruction है MVI, it will take how many T state? It will take how many T state to execute?
7.
Yes, NOP will take 4 T state, only opcode fetch. Yes, MVI will take 7 T state, opcode fetch and memory read. So 4 plus 3 will be 7. So 7 into T. T how we will calculate? By 1 upon F. So which is 0.5 microsecond if you are taking F equal to 2 megahertz. So 7 into 0.5 microsecond will be 3.5 microsecond. Are you getting this point?
Yes, ma'am.
Okay. Now same way, you need to find out loop delay. Loop delay मतलब ये instruction को execute होने में कितने T state लगते हैं? It will take 4 T state. JNZ और उसके बाद आप label लिख रहे हो 16-bit address we are writing. That means it will take opcode fetch, memory read. So 3 plus 3, 6 plus 4. So total 10 T state will be required by JNZ instruction. So 14 T state you are taking for this 2 instruction, and this 14 T state will repeat how many times? You are taking 4 T state, 10 T state to execute these 2 instructions. So total 14 T state you will take to execute these 2 instructions. Now this 14 T state will repeat how many times? You are repeat. Yes, so 14 T state, that is 14 into 0.5 microsecond, you are repeating how many times? 255 times. So that is nothing but your loop delay. Are you getting my point, student? Right? So 14 into 0.5 is 7. 7 into 255 is how much, student? क्या आंसर आता है इसका? What is answer? Make it fast.
1785.
1785. Correct. So 1785 microsecond, you will find by executing these two instruction, and 3.5 microsecond you will take to execute this instruction. So total time delay is the outer loop, which is 3.5 microsecond, 3.5 microsecond plus inner loop delay, which is 1785 microsecond. So total time delay हम लोग को क्या मिला? The total time delay which we are getting is approximately equal to 1788.5 microsecond. Are you getting my point, student? Right? So 1788.5 microsecond is nothing but the approximately 1.788 millisecond. Yes or no? Microsecond में अगर आप microsecond को if you convert it into a millisecond, then it will be around 1.788, which is nearly about 1.8 millisecond. Are you getting me, student? Yes or no? So if you will write this loop in between two count value, now by using this register technique, you will get an approximate delay of around, in terms of millisecond, which is approximately equal to 1.8 millisecond. Am I clear, student? Right? Any point that you want me to repeat, student? Is it clear, everyone? Yes?
मैम
Yes, please.
मैम ये सब कुछ तो समझ में आ गया, लेकिन डिले कैसे हुआ वो?
डिले कैसे हुआ? सी यहाँ पे आप काउंटर लिखोगे, काउंटर इक्विवेलेंट लूप लिखोगे. तो फॉर एग्जांपल यहाँ पे आपने लिखा है NDIS 09H, राइट? नाउ आप जनरली क्या करते थे कि उसके नीचे ही यू आर राइटिंग DCRA, राइट? काउंटर में यू आर राइटिंग DCRA. नाउ व्हाट यू विल डू इज, यहाँ पे NDIS 09 और उसको अपडेट कर रहे हो, इन बिटवीन दैट यू विल राइट दिस लूप. आर यू गेटिंग मी? तो ये लूप चलता जाएगा 1 मिलीसेकंड के लिए, 1.8 मिलीसेकंड में, देन यू आर डिक्रीमेंटिंग. दैट मीन्स you will provide some delay in between two count value. Am I communicating, Mukul?
Yes, ma'am.
Right? So this loop you will write in between two count value. Right? I hope I am clear with this statement. Right? Now, as we know, student, कि यहाँ पे हमने अपने रजिस्टर को मैक्सिमम वैल्यू से लोड कर लिया है. Now, after this, there is no value, no maximum value that we can load a register pair with register. So this is the maximum delay that we are getting through this method, right? ये टेक्निक से हमें maximum delay almost कितना मिल सकता है? Obviously, previous में microsecond में मिल रहा था, यहाँ पे we are getting approximately in terms of millisecond, approximately equal to 1.8 millisecond. But 1.8 millisecond से ज़्यादा delay you cannot provide with this method, right? Just for your reference, और आप इसका स्क्रीनशॉट ले लो या फिर यू जस्ट राइट दिस स्टेप्स जो हमने अभी मैन्युअली फाइंड किया, द सेम वे हाउ यू विल फाइंड टोटल डिले. सो वी नीड टू फाइंड आउटर लूप डिले एज वेल एज लूप डिले. हाउ टू फाइंड लूप डिले? सो लूप में कितने टी स्टेट है, मल्टीप्लाई बाय काउंट इन डेसिमल. सो इट विल से मेरे आउटर लूप में 7 टी स्टेट है और इनर लूप में 14 टी स्टेट है, बट दैट 14 टी स्टेट विल रिपीट टू 55 टाइम्स, राइट? सो टोटल 3, 5, 6, 7 टी स्टेट. एंड टी कैसे मिलेगा आपको? डिवाइड बाय फ्रीक्वेंसी करके. सो 3, 5, 6, 7 फॉर इनर लूप एंड 7 टी स्टेट फॉर द आउटर लूप. डिवाइड बाय फ्रीक्वेंसी, डिवाइड बाय फ्रीक्वेंसी करो या मल्टीप्लाई बाय टाइम करो, बोथ विल गिव यू सेम रिजल्ट. सो अप्रोक्सीमेटली 1.787 millisecond you will get, and that is the maximum delay that you can provide through this method, right? Any doubt up to here, student? Anyone? Yes, sir. Yes, please.
How it can ask you in exam?
See, Yes, that's what we are discussing in our next point. Okay, how to ask this thing into exam. We'll discuss it. But first tell me, in first two method, any doubt? Sakshi?
Yes, ma'am. What is minus 3? Why we have to do
Very good, right? That what I'm looking for, that someone will ask about it. -3. Thank you, Sakshi, for observing. Student, यहाँ पे जैसे मैंने यहाँ पे find out किया था, तो I'm writing 14th state multiply by 255. Yes or no? That what we had written? Yes or no?
Yes.
Okay. Now Sakshi, just try to understand कि ये लूप आपका 0 to 255 times execute होगा, right? You will start with 0 to 254 में जब आप पहुंच जाओगे, at that time, what you will do? You will come out of the loop. Yes or no? इसको आप FF से FE करोगे, FD करोगे, FC करोगे, right? When this condition is not fulfilled, you will come out of the loop, right? So total 255 times you are repeating, but last time your condition will not fulfill, so that you are coming out of the loop. So जब भी ये loop में रहेगा, JNZ will come in loop. At that time it will take 10 t state, but when you will come in last count value, when you will come out of the loop, at that time it will take 7 t state. Are you getting me, Sakshi? For example, आप 9 तक काउंट रखते हो. फॉर एग्जाम्पल यहाँ आपने 9 लोड किया है, सो 9 8 7 6. आप जब 0 पे पहुंचोगे तब ये इट विल कम आउट ऑफ द लूप. बट आप अभी क्या कर रहे हो? यू आर मल्टीप्लाइंग ऑल 255 विथ 14 पे स्टेट. बट उसमें से लास्ट में क्या होगा कि लास्ट में इट विल नॉट टेक 10 टी स्टेट. योर JNZ विल नॉट टेक 10 टी स्टेट, बट इट विल टेक 7 टी स्टेट. मतलब आपने 3 टी स्टेट ज्यादा ले ली है. आर यू गेटिंग माई पॉइंट, साक्षी? यहाँ पे each and every count starting from 0 to 254, it will take 10 t state, but in last count it will take 7 t state, because this condition is not fulfilled. मतलब आपने 3 t state ज्यादा ले लिए while you are multiplying, right? While you are multiplying, you had include 3 more t state which was not actually in consideration, so that you need to subtract. Are you getting me, Sakshi?
Yes, ma'am. Somehow. Ma'am. So
One more time, no, very interesting to understand. One more time I'm repeating, Sakshi. देखो ये आप MVI इंस्ट्रक्शन देख रहे हो. T state are fixed, 7 T state. If you are writing DCR, it will take 4 T state. JNZ जब आप कंडीशनल इंस्ट्रक्शन देख रहे हो, right? So if this 0 flag is not set, then it will go to loop. Loop में मतलब आप क्या दे रहे हो? 16 bit address, right? So it will take 3 machine cycle, opcode fetch, memory read. So it will take 10 T state. Are you getting up to this?
yes.
Okay. Now just think of last instance कि जब ये DCRC आपका 0 होता है, right? If your counter will become 0, that means this condition is not fulfilled. आप फिर से लूप में नहीं जा रहे हो, you are coming out of the loop. At that time what will happen? There is no need to read memory. ये आपको read करने की जरूरत नहीं है, because you are coming out of the loop. So at that time it will only take 7 T state instead of 10 T state. Are you getting me?
Yes, ma'am.
ओके. नाउ यहाँ पे आपने क्या किया कि 10 + 4 14 टी स्टेट आपने डायरेक्टली काउंट टाइम मल्टीप्लाई कर दिया, जिसमें से 3 टी स्टेट यू नीड टू सब्ट्रैक्ट. व्हाई? बिकॉज एट लास्ट पॉइंट, at last count, whenever you will come out of the loop, it will not take 10 t state, but it will take 7 t state. So that more 3 t state we had added, that we need to subtract here, right? तो आपका लूप में आपके पास 2 ऑप्शन है. या तो आप 14 को 254 टाइम्स मल्टीप्लाई करके 7 टी स्टेट्स ऐड करो, या तो 255 टाइम्स मल्टीप्लाई करके 3 टी स्टेट को सब्ट्रैक्ट कर दो. I hope I am communicating, right? Either what you can do is you will multiply 14 with 254 and you will add 7. You will add 7, or what you can do is count time. FF matlab 255 times. We are adding it. We are multiplying 14 P state with that, and that remaining 3 T state we will subtract. I hope I am communicating Sakshi. Right, now it's clear?
Yes, ma'am. Clear to me.
Okay. What about others? Mukund, Devang? Anyone? Any doubt? Harsh? Harsh is not giving answer. Madhvi is not giving answer. Drashti, can you hear me? Ayush? Ayush, જ્યારે એક્ઝામ આવે એનો સિલેબસ એની પીપીટી એવું બધું અપલોડ કરવાનું હોય ત્યારે જ એક્ટિવેટ થાય છે, એવું છે આયુષ? Ayush, can you hear me? Okay. So I hope these two things are clear to everyone. How to provide a delay by using one instruction and how to provide a delay by using register. Okay. Any last point to discuss here in this slide? Anyone? Mukund? Everything is clear? Dinesh, Kronal, Devang, is it clear, students? Naseeb? Yes. Now, just focus on the first task of experiment number 6. जैसे साक्षी ने पूछा था कि how this can be asked in exam. So just try to understand. Student, just read this 4 to 5 lines and tell me what is your interpretation from this. Just read it, read this line and tell me what is your interpretation from this. Sakshi, are you available? You left the meeting?
Yes, ma'am. Because of network issue, I have left the meeting.
Okay, so
Please write it once because I have left the meeting.
okay,
So
that's what I'm doing. Okay. So students, you can see here that we want to check here how this type of question can be asked in exam. Just read this 4 line and tell me what is your interpretation. आपका interpretation क्या है from this 4 lines, and then we will discuss. Okay. Just read it once and tell me what is your interpretation. Mukund, can you try? Mukund? Mukund, can you hear me?
Yes, ma'am.
Okay, what do you think? What can be done here?
No idea, ma'am.
No, just read it and interpret it. Interpretation તો આવડે ને, આપણે કરવું નથી. I am not asking to do this program. What I am telling you, what is your interpretation from this write-up?
मैम डाउन काउंटर डिजाइन करना है with
Very
1
good.
millisecond.
Very good. See, from this first line, student, everyone will understand कि we want to design. पहले तो हमें type of counter that we want to design, that we have to decide first, right? तो यहाँ पे हमें ये पता चल गया from the first line that we want to write a program which will generate which will use to count down from FF to 00. Are you getting me, student? तो हमने पहले डिसाइड कर लिया कि हम लोग को अप काउंटर डिजाइन नहीं करना, वी वांट टू डिजाइन अ डाउन काउंटर. वेरी गुड. नाउ व्हाट you are getting from this last two line, Mukul? Yes.
हर एक काउंटर के बाद 1 मिलीसेकंड का डिले होना चाहिए.
Very good. Students, as we discussed, to design a counter is not only task that we need to do, we need to provide some delay in between two count. Right now we know two methods to design to generate a delay, which is first method is NOP and second is using register. What do you think? Which method we should use? We need a delay of 1 millisecond in between two count. So what do you think? We should go with first method or we should go with second method? Yes, please go ahead. Give answer. You need a delay in terms of milliseconds, student. So what do you think? We should go with first method or second method? Sakshi, Devang, Dinesh, what do you think? आपको मिलीसेकंड में डिले चाहिए, सो व्हाट यू विल गो फॉर? फर्स्ट मेथड में आपको कितना डिले मिल रहा था स्टूडेंट्स? हाउ मच डिले यू आर गेटिंग थ्रू फर्स्ट मेथड?
Zero point 0.5 microsecond.
Okay, can you hear me now, student? Am I audible?
Yes, ma'am.
Okay. So the student, the discussion that we are making here is what do you think? Which method we need to use? My screen is visible, student?
Yes, ma'am.
Okay. So as we have discussed, that we want to generate, we want to design a down counter which will count down from FF to 00. That's why it is known as hexadecimal counter. We want to make it continuous, मतलब एक बार count करके हमें वापस नहीं चले जाना, but again it should load to the FF, right? So how to design that counter is clear to us. But now the question is how to provide a delay. We had discussed two methods, student. One is using NOP and another is using register. Now to get 1 millisecond delay, what do you think? Which method we should use out of first two? which method we should use to provide a delay of 1 millisecond. Mukund? Am I audible? Hello?
Yes, ma'am.
Okay. See, student, यहाँ पे हमने डिस्कस किया था कि थ्रू फर्स्ट मेथड वी आर गेटिंग अ डिले ऑफ हाउ मच, कितना डिले मिलता है हमें फर्स्ट मेथड से? Student, it is in front of you. How much delay we are getting? 2 microsecond, right? And here we need to generate a delay in milliseconds. So should we go for first method, student? Or we should move to the another method? कि जहाँ पे approximately हम लोग को कितना delay मिलता है? Wait, find that we are getting a delay in terms of 1.8 millisecond approximately. So 1.8 millisecond is greater than 1 millisecond. So you can use which method out of first two to generate a delay?
Register technique.
Second method, right? Using register technique, right? And to set up your delay loop, you will use register C. And Dinesh, आप जैसे t कंसिडर करते हो 40, 70, उसमें t क्या होता है? So that t you are getting from f. So generally या तो आपको f दिया गया होगा या directly t is given to you. You can see here that t equal to 0.5 microsecond is given to you. Right? जब भी आप delay find out करोगे, at that time you need the value of t. तो दो ऑप्शन हो सकते हैं, या तो आपको f दिया होगा, then you need to find t, या तो directly आपको t is given. Here t is given directly. Okay, so that is our task for today. Where we want to, I'm concluding this. Just try to understand where we want to design a down counter which will count down from ff to 00 continuously, and we need to provide a delay in between to count, which is through register method. Any doubts, student? Can we understand this? Yes or no? Are we able to understand this? Naseeb? Devang? Sakshi? Yes, please, Mukund.
मैम डिले 1 मिलीसेकंड का है तो वो t इज इक्वल टू 0.5 माइक्रोसेकंड क्लॉक पीरियड वो किसके लिए है?
मुकुंद, एज आई डिस्कस कि यहाँ पे आप देखो, यहाँ पे आप t फाइंड आउट करते थे, t, राइट? यू नीड टू फाइंड दिस 7t, 4t, 10t, इसमें t क्या है? व्हाट इज द वैल्यू ऑफ t? सो दैट t यू नीड टू फाइंड आउट क्लॉक पीरियड. समझ रहे हो? 1 millisecond delay. 1 millisecond delay is a total delay that you required in between two count value. But उसमें आप जैसे you are taking कि 14t is repeating 255 times, तो वो आप t कैसे find out करोगे? Clock period जिसको बोलते हैं, right? So that t you can find out. जैसे कि यहाँ पे आपको दिया गया है कि frequency is 2 megahertz. यहाँ पे आपको दिया गया है कि फ्रीक्वेंसी इज 2 मेगाहर्ट्ज. तो या तो आपको फ्रीक्वेंसी दिया होगा या तो आपको डायरेक्टली टी दिया होगा, राइट? यहाँ पे आपको डायरेक्टली टी दिया है, राइट? हियर यू विल फाइंड डायरेक्ट टी. माय वॉइस इज क्लियर, स्टूडेंट?
यस मैम.
ओके, सो दिनेश, मे बी योर साइड देयर इज अ प्रॉब्लम. कि हम लोग कैसे कर सकते हैं? So first of all, आप counter design कर लो, which will count down from ff to 00. So what instruction I should write? Very first instruction is, मैं कैसे ये लिख सकती हूँ, काउंटर को कैसे डिजाइन कर सकती हूँ? Yes. Make it fast, student. How can we design a counter which will count from ff to 00? NVI?
F.
A. Very good. NVI A FFH, and then we will पहले counter design करो, then we will think of delay, right? Then what we should do after FF? We should decrement it. Yes. And then we will check whether it will become 00 or not. And then if not, then we will again go to L1. It is 0, 0. Then we will move to L2. So it is a continuous count from FF to 0, 0, which is known as hexadecimal counter, right? Okay, now assemble it. VIA, change ZL1. Screen is visible, right, student? So now you can see it will execute it. It will work as a down counter, hexadecimal down counter. Can you see here, student, content of accumulator? Yes or no?
Yes, ma'am.
Correct. Now if we'll find it, all right, if we'll find it, it is a hexadecimal down counter. You will run it. You can check that count down is there, but we are not able to observe, right? So now what is the task that we need to do is कि आप ये अपना accumulator में count value ले रहे हो और उसको decrement कर रहे हो. In between that you need to provide a delay, right? तो यहाँ पे आप कौन सा loop से fade कर दोगे? Which loop you are writing here? Yes. MVI, C, FFH, ECRC, JNZ, L3, and that L3 will write here. तो हम लोग ने क्या किया स्टूडेंट्स? आर यू एबल टू अंडरस्टैंड कि यहाँ पे काउंट वैल्यू लिया, in between count and its decrement we had put some loop which will execute to 55 times, so we are getting some time. Just try to understand कि ये कैसे वर्क करता है. देखो ये FF कितने टाइम तक रहेगा? How much time it will hold in accumulator? Can you see here, student? Still it is FF. वो कब तक रहेगा FF? मुकुंद?
1.7 millisecond.
1 approximately equal to 1.8 मिलीसेकेंड तक वो FF यहीं पर रहेगा, राइट? ये आपका रजिस्टर से जब तक 0 ना हो जाए तब तक you will find that your accumulator will hold that data, right? So you are in a position to provide a delay in between two count value. Am I communicating, student? पहले क्या होता था? Directly ये decrement हो जाता था, so we are not able to observe, but now it will hold up to approximately 1.8 millisecond. So easily you can see कि जब तक ये आपका रजिस्टर से 0 नहीं हो जाएगा तब तक ये accumulator में FF ही रहेगा, then it will go to FE, then it will go to FC and so on. I hope I am communicating, students. Any doubt here in this? Yes or no? Sakshi, Sanskar, Shubham. Any doubt, student? Pranal, Vishwa, Shruti, Savan, Nasir. Is it clear, Sarsh? Right? Okay, Mukund? Then?
Yes, ma'am.
Okay, so now Sakshi, answer to your question is how it can be asked in exam. One thing, it can be asked in terms of this kind of program, right, where you need to design a counter and in between to count you need to provide some delay, right? So whatever program we did, that kind of question can be asked. Second theoretical question can be discuss the different technique that is used to generate a delay. Are you getting me, Sakshi? So in that, the process you need to discuss, right? So that is the level of question is understanding, where you are understanding the different technique. But if it is asked that provide this much of delay in between two count, that is of application level, where you are applying this knowledge of generation of delay into your program. I hope I'm clear, Sakshi. Alright. So two kind of questions can be from this. One is program and the second can be the theoretical question where you need to discuss your generation of delay. Students, we discussed first two method. Two more we need to discuss by next lab, and depending upon that, we will check out last two tasks, which is basically focusing on waveform generation, right? Where we are generating square wave and rectangular wave. So these two tasks we will perform by next lab. Okay, anyone, any doubt, any last point to discuss up to here? Yes or no? So, students, you will make sure that by today evening only, you will complete your first task. You will write all these things into your classwork book because we are not going to repeat it in theory. So, make sure this should be in your classwork book. And by next lab, we'll complete this experiment 6 and then you need to upload. Is it clear, student? Okay.